Okay, in this video we're going to do some practice problems to get ready for the test that's coming up. And our first batch here, question number 1, find all numbers that must be excluded from the domain of each rational expression. Remember, rational expressions look like fractions, and what don't we want in the denominator of a fraction? Of course, we don't want a 0. We can't divide by 0. So to find out what numbers to exclude, I'm going to concentrate just on the denominator and set that denominator not equal to 0. And to solve for x, of course, I would subtract 5 from each side. So in our first one here, letter A, the domain is all real numbers except x. Except x equals -5. Letter B now. I see I got a difference of squares down here, and we've been factoring for a while. So I am going to factor my denominator into a sum and a difference, x plus 6 and x minus 6. And I'm going to set that not equal to 0. And then the zero product property tells us I set each of them individually not equal to 0. So in the first one, I'll subtract 6 from each side and get x cannot equal -6. And for the other one, I'll set x minus 6 not equal to 0, add 6 to both sides, so x cannot equal 6. Or to sum it up, x cannot equal positive or negative 6. Either of those numbers will cause a division by 0. All right, the last one here, we got another polynomial. It's not a difference of squares, but we just got to find the factors of -14 that add up to -5. And let's see, there's not many factors of 14. 1 and 14, 2 and 7. 2 and 7 are 5 apart on the number line, so I know it's going to be a negative result, so I want the bigger number negative. -7, +2. Oops. -7, +2. And just like letter B, we're going to set each of those not equal to 0. What number zeroes out this term? Well, that would be 7 minus 7. So x cannot equal 7. And what number here added to 2 would equal 0? Well, that would be a -2. So x cannot equal a -2. All right. Number 1, not too hard. They will get a little tougher. Number 2, simplify. When I see simplify, I'm thinking factor and reduce. So if I look at this numerator, I can factor out common terms. There's no numbers in common, but I can pull out an x squared. And if I pull out an x squared, that leaves an x plus 3 inside. Oops. X plus 3. And look at that denominator, x plus 3. These problems are set up and designed to be solved and have cancellations like this. So for number 2, A, our final answer is just x squared. Okay, now when I look at B, I see a numerator and denominator. Each of these are going to be factorable, and I think the easier one to factor is the numerator, difference of squares. So I'll quickly factor that into an x plus 1 times an x minus 1. Now my denominator, here I have some clues. One of those is probably going to be a factor in the denominator. X plus 2 plus 1, or x squared plus 2x plus 1. What are the factors of 1? Got to be 1 and 1. And it's got to be addition because everything in here is positive. And we got 1 cancellation. So our simplification here is just x minus 1 over x plus 1. And if, we'll forget that. Number 3, multiply. Don't think that you're going to parenthesize these off and start, sort of foiling this out, distributing, because that would just be a huge endeavor and get very sticky very quickly. But I see things that can be factored. I see this x plus 3 right off the bat. That can't be factored any farther, but that's going to be a clue. Maybe I'll have an x plus 3 below it or on the diagonal over here. And it's not going to be x squared minus 4. Well, that's an easy one to factor. Let's get that out of the way. A sum and a difference. X plus 2, x minus 2. Now here on the left we have clues as to what some of our factors over here might be. Again, for the denominator, I know it's got to be x and x for the x squared. Everything is positive, so these are positive. X plus 3 is probably going to be one of these factors. What are the factors of 9 that add up to 6? Well, that would have to be 3 and 3. Now up above, we got an x squared minus x minus 6. Again, we might have an x plus 3 in there, or we might have a minus 2 or a plus 2, and get some cancellation on the diagonal. So our x squared comes from x and x. The factors of 6, 6 and 1, or 2 and 3. 2 and 3 are 1 apart on the number line, so that'll be a minus 3 and a plus 2. Okay, we are multiplying, and we're simplifying also here, so plus 3 is on the diagonal. We got a plus 2 here and a plus 2 here. And that looks like it. So our numerator has been reduced to an x minus 3. Our denominator is now the x minus 2 from here, and this x plus 3. There we go. Number 4, divide. Remember, when we divide, we multiply by the reciprocal. So here on the left, I can start off by factoring. My denominator, it looks like I can just pull an x out of there, and then I'll have an x squared plus 1. Can we further factor x squared plus 1? No. If that was a minus, if it was a difference of squares, we could, but this is a sum, and we cannot factor that any farther. In our numerator, the x squared has to come from an x and an x. The factors of 1 are only 1 and 1, and we want them to add up to a negative 2 in the middle, so it's got to be minus and minus. And we would multiply the minus 1s and get the positive 1. So right now, I'm going to change this division to a multiply, and I'm going to imagine these flipped upside down. So this will be my numerator, and I'm going to factor a 3 out of that, and it's going to be a numerator here. Ooh, and look at that, x squared plus 1. We can't factor it any farther, but we will be able to cancel that on the diagonal. The numerator from here is now going to be my denominator from my flipping, and that has to be x and x. The factors of 2 are only 2 and 1, and we want to wind up at a positive 1 in the middle, so it's going to be a positive 2 and a negative 1. And it's time to cancel. The x squareds plus 1 go away. On the diagonal, x minus 1, x minus 1. So it looks like the only things left in our numerator are 3 times this quantity, and I'm not going to distribute. Might as well leave it in factored form. And down in this denominator, I have an x times an x plus 2. And that looks like as far as we can go. Okay, subtracting. Remember, to add or subtract, we need a common denominator. And this is a nice one. We have a common denominator already. So I'm going to come down here and do my division line and put my common denominator under it. We have this piece of the numerator, x, and then we're going to subtract this other numerator. And remember, we have to subtract this as a quantity. So we're subtracting the quantity of 3x plus 2. So in our next step, we'll distribute that negative sign, negative to the 3x. The negative to the positive 2 now makes that a minus 2, and our denominator is x plus 1. Can we go any farther? We can combine like terms in that numerator. So we have an x minus 3x. Well, 1x minus 3x is negative 2x, and a minus 2. And our denominator is still x plus 1. Gee, it looks like we're done, aren't we? Don't stop until you exhaust all possibilities of factoring. What can I pull out of that numerator? Well, I can pull out a 2, but can I just pull out the negative with it also? If we take out a negative 2, what remains in the parentheses is, aha, x plus 1. Look at that. So those, of course, are going to cancel, and our final answer is just negative 2. So all of this, even with the variables, all these x's, it boils down to just a number. No matter what we plug in for x, our answer will always come out as a negative 2. Now here, we do not have common denominators. So the common denominator that we will use to add the fractions will be these two separate ones multiplied together. So my common is quantity x plus 1 times quantity x minus 1. And now my numerator, this piece of the numerator 3 had under it already the x plus 1, but it's missing the x minus 1 component. So we're going to multiply that numerator by what was missing under it. And then we have a plus 5. The 5 already had this component of our common denominator, x minus 1, but it was missing the x plus 1. So we multiply the numerator by what was missing underneath it. Oops. Okay. A little more algebra here. My common denominator is not going to change for now. If you feel the need to FOIL that out, I wouldn't, because we might have something cancel in the future. Ooh, now this is a common mistake. I might see students do this. Ooh, x minus 1, x minus 1. You cannot factor that out unless that term also occurred in both terms of the numerator. We have 2 terms in the numerator, and we'd have to factor out common terms of all of them, and that is not the case. Same for the x plus 1s. So let's distribute the 3. So that will become a 3x minus 3. And distribute the 5, 5x plus 5. And we can combine like terms and see if maybe we have the opportunity for another cancellation. Okay, 3x, oops, why is that yellow? 3x plus 5x is 8x. Minus 3 plus 5, or 5 minus 3 is positive 2. And then we have our x plus 1, x minus 1. And in my numerator, I see variables aren't there, but I could factor out a 2. 2 times the quantity 4x plus 1 over the common denominator. Quantity x plus 1 times quantity x minus 1. Okay, these are getting a little trickier, but now it's time to turn the paper over and get to the back, where things will get kicked up a little bit, kicked up a notch. Here we're not asked to add or subtract. We just want to find the least common denominator. Remember, we had some steps in the book. We are going to first factor this as far as we can. And if we factor that, we're going to get an x minus 3 times quantity x minus 3. And I'm going to switch over to blue. And if I factor this denominator, it's a sum and a difference, an x plus 3 and x minus 3. So now we want to come up with the common denominator. And the steps in the book said, of course, we're going to use this entire first factored denominator in its whole, entirely. So x minus 3 times x minus 3. Now we want to bring down any pieces from over here that aren't already represented. Well, here's an x minus 3, but we're already represented with that twice, so we don't need to bring that down. But this x plus 3 is different, so we're going to bring that down, and that will become part of our common denominator. Again, I would not FOIL these out and then do it again, because at the end of the problem you might have a chance to reduce again. Now we're going to need to use that little skill here in number 8. If you got your paper with you, this 10, the 0 here might have been punched out by the hole punch, so that is a 2x minus 10. And to find our common denominator, we could multiply these together and then sort of cross-multiply to fix up our numerators, but that's going to turn into a very big and complicated problem. That method works well if our denominators are fully factored, and here they're not. So we can factor this into an x minus 5 times x minus 5. And here we can factor out a 2. 2 times the quantity. Ooh, x minus 5. Look at that. So what is our common denominator going to be? Well, we're going to bring down these pieces together. Quantity x minus 5 times itself. And then here we have an x minus 5, but that's already been represented. But even this number is going to have to come along. We need that 2 represented in our common denominator. So let's fix up our numerators. This component of the numerator in the first term had an x, and we need to multiply what is missing underneath it from the common denominator. Well, we have these 2 down here, but we're missing the 2. So this x is going to get multiplied by 2. And then we have minus this quantity x minus 4. So minus quantity x minus 4. Under this numerator, oops, didn't mean to do that, we have these 2 pieces of our common denominator, a 2 and an x minus 5. Well, we have a 2 and an x minus 5 here, but we need another x minus 5. So this piece of the numerator gets multiplied by an x minus 5. Now the order of operations are going to say to work in the parentheses first, so here we're going to FOIL these out. And after we FOIL them out, remember they will still be in grouping symbols because this is a quantity, and we'll have to distribute the negative sign. So let's get started on that. Okay, that first piece of the numerator here, 2 times x is 2x. And then we're going to have minus, and I have my bracket, and I'm going to FOIL this out. That's going to turn into an x squared minus 9x plus 20. And the common denominator will stay in its component pieces. Okay. Let's distribute the negative across the brackets, combine terms, and see if we can factor and cancel anything else out. So distributing that negative, we'll switch every sign in the brackets. Now it's a minus x squared, a plus 9x, and a minus 20. And that's all over the 3 pieces of the common denominator. So combine like terms, and look for any other chances to factor or reduce. Start with my highest power. I'll have a leading negative x squared. And then I have a 2x plus 9x. Well, those add up to 11x's. And then we have our minus 20 at the end. All over 2 times x minus 5 quantity times another quantity, x minus 5. So we might have a little hope of factoring the numerator and canceling something with the denominator. This 20, the only way to get the factors of 20 would be 4 and 5. And there's no way 4 and 5 are going to add or subtract to give us an 11 in the middle. So it looks like that's as far as that can go. You know, we started out with something that was pretty nasty, and we got it down to a little more workable form. And here it's at least one term. You know, we don't have to subtract anything. All right, number 9. Ooh, look at that. I'm going to move this over here and make it a little bigger. We have a complex fraction. Fractions in the numerator and then fractions in the denominator of an overall more complex fraction. So let's divide and conquer. First, I'm going to look at this numerator up here in blue. 2 fractions, I want to get the common denominator, so I'll multiply these together. Common denominator up here is a 2x. And then to fix my numerator, I'm going to multiply the 1 by what was missing under it, or sort of on the diagonal. 2 times 1 is 2. And then here we have a minus 3 times x, or minus 3x. So I condense the numerator into its own single fraction. Do the same in the denominator. The 2 denominators I'm given down here are 4 and x, so I multiply those. And I'm sort of going to multiply up to the left. That'll turn into a 4. Plus 3 times x is 3x. So now I have a single fraction up here divided by a single fraction down here. I can invert and multiply. Multiply by the reciprocal. So I'm going to bring this up and flip it, and this will turn into a multiply problem. Now my 4x is in the numerator, and 4 plus 3x is my denominator. So is there anything here I can cancel? Well, if I look on this diagonal, these x's will cancel. And then I can treat the 4 and the 2 like a fraction. 4 over 2 will reduce. If I divide by 2, this divides out to a 1. And 4 divided by 2 is 2. So let's see what we're left with. If I multiply across the top, I have this 2 times this quantity. So 2 times quantity 2 minus 3x. Denominator, the only thing left down here is this quantity, 4 plus 3x. And since that's the only thing in the denominator, we don't need parentheses around it. Don't try to reduce these. You can't do it because we have multiple terms. Don't try to reduce the 2 and the 4 because this 2 is multiplied, but here we have 4 plus 3. We're adding those terms. We can't go reducing anything like that. All right, let's see what's on the next page. Number 10, simplify. Now this is a different kind of complex fraction. We just have 2 fractions in the numerator, and our denominator down there is just a lonely little 7. Whenever I see something like that, I always remind myself that's a 7 over 1, because at some point we are going to flip that and invert and multiply. So let's see. We have our 7 over 1 down here. Up top, the 2 denominators I have are x and the quantity x plus 7. So those are multiplied to get our common. And then I'm sort of going to multiply up this way. 1 times x is x. And when we multiply up this way, here's where the negative comes into play. This is negative 1 times that quantity, or negative times the quantity x plus 7. Again, don't do that. That would not be a legal move. So let's see. Working up there in this red part of my overall fractions numerator, I can distribute this negative. So that is going to turn into x minus 7 over my denominator x times quantity x plus 7. And that's still over 7 over 1. So we're getting close here. We might be able to do it in one more step. X minus x, well, that turns into a 0. So we have a 7 left, and don't forget that is a minus 7. That negative is not going anywhere. And we still have this x times quantity x plus 7. And this would be a good time to multiply by the reciprocal. I'm going to bring this up and turn it over. Now it is times 1 over 7. And it looks like we have one more cancellation or reduction here. On the diagonals, we have 7s. So those are going to cancel out to 1s. Divide by 7 and you get a 1. Again, don't forget the negative sign. That's still part of our answer. If we multiply across, we have a -1 numerator. And our denominator is x times quantity x plus 7. Alrighty, I think there's 13 problems on here. So what are we on to next? Number 11. Holy cow, look at that thing. Everything I look at up there is chances to factor. We have one fraction times another, and then this is division. So when we get down to this one, we're going to turn this into a multiply and then flip this over. Multiply by the reciprocal. But let's get started. Our first numerator. We got to factor that into a couple binomials. The factors of -12 that add up to a +1 have to be 4 and 3. A +4 and -3 will add to +1, multiply to -12. Below it, above us, we might have clues to what the factors might be down here. Of course, that's going to be x and x. Factors of -30 that add up to 1. Or what numbers do you multiply to get 30 that are only 1 apart on the number line? 6 and 5. 6 and 5. And since our final result is positive, it'll be the bigger number, positive 6, and the smaller number, 5, will be the negative. Times. Now here, when we're factoring these, if you get a little stuck, look for clues on the diagonals, because that's where is a possibility of reducing. Numerator here, factors of 6 that add up to 5. Everything is positive, so it has to be 2 and 3. 2 and 3 add up to 5, multiply to 6. Below, the x and x produce our x squared. Factors of -3 that add up to 2. Well, the only factors of 3 are 3 and 1. And to get them to add up to a -2, it would be a -3 and a +1. Last component here, again, this is dividing by a fraction. So we're going to multiply and then flip it over. This numerator is now the denominator, and that's already as low as it's going to go, x plus 3. Now if we factor here, the factors of 6 that add up to 7, everything's positive, has to be 6 and 1. All right, time to see what cancels. Let's see. On this diagonal, x plus 6, x plus 6, x plus 1, x plus 1, x plus 3, x plus 3. Oh, x minus 3, x minus 3. Look at all of that. It looks like that as far as we're going to go. So what's left in our numerator? These two terms, x plus 4, x plus 2. And denominator, quantity x minus 5. And that looks like the show is over. Check that on my answer key here. Yeah, we got it. Okay. Number 12, simplify. Another one here. We got 3 terms, but we are adding and subtracting, so of course we're going to need a common denominator. I see here those are nice bite-sized chunks. Let's see what happens when we factor this bad boy over here. Well, the factors of -20 that add up to 1 have to be a +5 and a -4. And lo and behold, that's our 2 factors over here. So our common denominator, we've already found it. Quantity x plus 5, quantity x minus 4. So this piece of the puzzle, this numerator, had the complete common denominator under it, so we can leave it alone. Just bring it down as is. Now the next numerator piece here is a +3, and under the +3 we had the x minus 4, but what are we missing? We're missing the x plus 5. So the numerator gets multiplied by what was missing under it. Our next numerator piece is minus 5x. Underneath the minus 5, or the 5x, we have this x plus 5 component. We are missing the x minus 4. Okay. So I think the hard part's over. Now we just got to do a little distributing, combining like terms, and looking for other chances to reduce. Okay, so again in this numerator, that first part is going to be unchanged. Our 6x squared plus 17x minus 40. And when we get to here, we got to distribute the 3. So that'll be a plus 3x plus 15. And then we distribute the minus 5x, so that will turn into a minus 5x squared, and a plus 20x. Wow, that's a lot of stuff. All right, and our denominator again, don't FOIL it out. We might have a chance to reduce near the end. And we're getting close to the end. So let's combine some like terms. And I like to underline as I go. Here we have a 6x squared minus 5x squared, so that leaves us 1x squared. And let's see here, we got a 17x and another 3x. That takes us to 20x. And then this takes us to positive 40 plus 40x. And let's see what we're left with here. 15 minus 40, or negative 40 plus 15, either way you slice it, is minus 25. And our common denominator is still x plus 5, x minus 4. Now the question would be, could we factor this numerator? I'm kind of doubting it. But we know we could have a plus or minus 5. Well, the only way to get 25 would be 5 times 5. There's no way we're going to get 40 in the middle. So this looks like our final answer. Okay, I think we got one more to go. Lucky 13. Ooh, this one looks like fun. I'll move this over here, make it a little bigger. We can sort of approach this the same way we've done the one earlier here. I'm going to turn this into a 1 over 1, of course. And we're going to attack the numerators and denominators separately here. So the first one up top, I have these quantities, and if I multiply them together, I would get my denominator up here as x minus 2. And then I multiply up. 1 times x is x. And then 1 times this quantity x minus 2 is x minus 2. And I'm going to drop the parentheses since we're adding and sort of save a step there. We'll come down here to this. And I see this denominator. Ooh, I know that's going to factor, and that's a factor of it, so that's going to come into play later. But right now I'm going to multiply across, and my denominator's denominator is the x squared minus 4. And if I multiply up this way, 1 times 3 is 3. And then 1 times this is going to be x squared minus 4. Ooh, I like where this is going. So back up top, I'll switch back to blue. X plus x is 2x. 2x minus 2 over this quantity, x minus 2. And coming down here, I have an x squared, and then 3 minus 4 is negative 1, or x squared minus 1. Ooh, I like that. And this might even be a good time to factor this denominator. X squared minus 4 is x plus 2, x minus 2. Okay. Yeah, I'm just going to leave, well, I see here, if I think of that as parenthesized off, I can factor out a 2. 2 times quantity x minus 1. Below it is my quantity x minus 2. And this is a good time to multiply by the reciprocal. I'm going to bring this up, flip it, and turn it into a multiply problem. So now this is my denominator, and let's factor that into its x plus 1, x minus 1 pieces. And this will now be the numerator. X plus 2 quantity times quantity x minus 2. And it looks like we'll have a good amount of canceling going on here. X minus 2 on this diagonal, x minus 1 on this diagonal. So what's left in our numerator is 2 times the quantity x plus 2 divided by quantity x plus 1. Whew, that was a tricky one, but I had fun. So the test will be coming up shortly. I'll see you in class.